Chapter 9, we're covering some trig facts. We're looking at the cosine rule, the sine rule, the area of a triangle is halfway b sine c, and we're looking at shapes of graphs. Now, all of those things are actually on the GCSE syllabus, and what you find is that this chapter is a reminder of some of the harder things from GCSE, and it's just getting us to the point where we can do those things really easily, okay? So I'll do a few bits and bobs. We'll derive the sine rule and the cosine rule, and we will do perhaps one or two examples. But really, this is a case of being able to do sine rule, cosine rule, and difficult trigonometry questions, and do them easily enough so that we're prepared for the later chapters. So let's have a look first of all. Sorry, that's left over from binomial. Let's have a look first of all at the cosine rule. Now, the idea here is this. We know Pythagoras' theorem, right? We have a rule for right-angled triangles, which is Pythagoras' theorem. Wouldn't it be nice if we had a Pythagoras theorem which would work if we didn't have a right-angled triangle? And we're going to introduce this new notation, A, B, and C as capitals for the vertices or the angles, and then A, B, and C as lowercase letters for the sides, okay? Now, what I'm going to do, oh, and the A is opposite the A, the B is opposite the B, and the C is opposite the C. Now what I'm going to do is I'm going to draw this line down the middle, which is at 90 degrees to the bottom, and I'm going to say that that length there is H, okay? Then this distance from here to here is going to be little x, and this distance from here to here is going to be C minus x. Now the idea is I would like some sort of rule, a bit like Pythagoras' theorem, which covers this non-right-angled triangle. So in other words, we want it to be in terms of A's, B's, and C's, okay? I've introduced the C and the H just to hopefully help me along the way. Now, if we look in this triangle here, we can see that b squared equals h squared plus x squared. And if we look in this triangle here, we can see that a squared equals h squared plus c minus x squared, okay? Now, if I look at those two equations, I can do this one, take away this one, for example. We can do a squared minus b squared equals c minus x all squared plus, minus x squared. So if that's equation 1, this is equation 2, and I do equation 2, take away equation 1, then we get that. And if we work with this, we get a squared, I'm going to move the b squared over this side, b squared, expand these brackets, c squared minus 2cx plus x squared, that's from expanding the brackets, and then take away this x squared at the end, and those x squareds obviously vanish. So we get a squared equals b squared plus c squared minus 2cx. So you can see, look, we've almost got Pythagoras' theorem. A squared equals b squared plus c squared, and we've just got to adjust by this little cx bit here. Now, if you look at x, well, cosine of angle A is x over b. Okay? So just in this triangle here, adjacent over hypotenuse, so x equals b cos angle A. So let's just replace the x in this equation here with that. A squared equals b squared plus c squared minus 2c times b cos A. So I'm going to write that as bc cos A. And there is the cosine rule, which we know from GCSE that we're familiar with. We can rearrange it if we want to into this form here. Now, the difficulty here is your triangle that you're dealing with won't necessarily be labelled with the A's, B's and C's in the order that you want them to be in. So if we take even the very first example from the book, they've labelled it this way around, C, A, B, and this is 6.5 and this is 8.7. So little a is 8.7, little b is 6.5, capital C is 100 degrees, and we want to find little c. And this formula, obviously, if you look at this, there's only one angle involved, and that's labelled A. So how do we deal with this? Well, there are three different ways of dealing with it. One is to have three different forms of the cosine rule. One with a squared equals b squared plus c squared minus 2bc cos A. One with b squared equals a squared plus c squared minus 2 AC cos B, and then the same with the c squared here and the capital C here. So you can memorize 3 different versions of the cosine rule. And then if you like memorizing formulae, you can rearrange and have this version of the cosine rule and memorize 3 of those as well, which is fine. But then all I've got to do to mess that up is, instead of labeling it A, B, and C, I'll label it X, Y, and Z, and suddenly none of your formulas work. So that's not a great way forward. Another way forward, which I would recommend, at least if you are fairly new to this, if you're not feeling too confident, is just relabel your triangle. So here, A squared and capital A, the sort of pair involved, the side and angle pair that are involved, are labelled A and A. So I'm going to relabel this as A, this is capital A, and then that means I'm going to have to relabel the A as capital C and little c, and now my formula will work. Okay, so the side involved and the angle involved as an opposite pair have to be labelled A if I want to use exactly this formula. And the other way of dealing with this is just not to worry about the A's, the B's and the C's. Just see this as B and C are a pair of sides, and between side B and C has got to be angle A. Okay, if you think about that, if you've got any old triangle, if you've got side B and side C, opposite angle B and opposite angle C, then the angle that's between B and C has to be called angle A. Okay? So the B and C are a pair of sides that are next to each other. The angle A is the angle in between them. And then this A squared is the angle opposite the angle that you've got. So a lot of people remember the sort of rule of thumb. If you've got a cosine rule question, it has to involve a pair of sides and the angle in between them. Either way, I'm going to leave you to look through example 1 and example 2 in the blue boxes, because after you've got to this point, after you've worked out what goes where A, B and C are, it is just a case of using the formula, substituting everything in. The tricky bit is realising whether you've got to use cosine rule or sine rule or some other formula, and in this exercise we know it's always cosine rule. Okay, you might need to revise a little bit of bearings to do things like example 3, and they can set you slightly nasty ones like in example 4, but it's probably a case of going back to GCSE revision. So I'm going to move on to section 9.2 in the next video.